Okay, hello. I'm back, Miss Awinu, your grade 10 maths teacher. Okay, in our last lesson, we looked at Pythagoras theory. Remember Pythagoras? Okay, when we are applying the Pythagoras theory, we're using squaring and taking the square roots. So today, we're going to have to look at those in a little bit more detail. Okay, so let's have a look at, please take note of our symbols. Okay, so we are looking at squares, okay, and square roots. All right, now we are very familiar with the first 12 square roots because they appear in our times table. Okay, now the first square root is generated. Now we have to look at the definition first. Squares are generated when we multiply a number by itself. Okay, so if I were to find the first square number, I multiply 1 by itself. Okay, so that's the first square number. Then we have 2 times 2, which is 4, 3 times 3, which is 9, and so on. Like I said, you are familiar with the first 12 square numbers. Now, it would be interesting and it would do you well to learn at least the next, say, 8 square numbers on your own. So you can keep that for your lesson time. Okay, now, because we are looking at Pythagoras, we need to look at squaring and square roots, like I said before. But here we are multiplying a positive number by a positive number to get a square number. You can also multiply negative numbers by itself, decimals by itself, and fractions by itself in order to get square numbers. Okay, now let's have a look at a few of these examples. First one, let's see the number negative 5. Okay, negative 5 squared, when you see this, you know that negative 5 will be multiplied by itself. All right, so that gives us a value of 25. Now, let's look at another number. This time, let's see decimal number. Okay, again, when you see a number like this, you know that you are multiplying 0.4 by itself. Okay, so 0.4 multiplied by 0.4. Now, I hope we did not forget this skill. When you are looking at multiplying decimals, you first need to count the number of decimal places in the question. So here we have 0.4 and 0.4, that is 2 decimal places. Then you multiply the numbers that are in the question. 4 times 4 is 16. Okay, and because there are 2 decimal places, we have to move our decimal point twice. So your final answer will be 0.16. Okay? Now that's what we do when we are squaring numbers. Now on the other hand, when you take the square root, a square root is finding the number that was multiplied by itself to give you a square number. Okay, so for instance, let's look at the first 3 examples we have on the board. Okay, if we are asked to find the root of 1, okay, you go back here. 1 times 1 is 1, so that is the answer. The square root of 1 is 1. Have a look at the second one. Root of 4. 2 times 2 is 4. That means square root of 4 is 2. Next one, square root of 9 is equal to, we know that 3 times 3 is 9, so the root of 9 is 3. Okay? So, squaring a number, when you square a number, you are multiplying a number by itself to give you a square number. Whereas the square root, you are finding the number that was multiplied by itself. So what we're going to do now, have you thought about what or how you would take the square root of a number that is not a square number? Okay, we've looked at square numbers 9, 4, 1. Other square numbers like 36 and 49, it is easy to find a square root. But what if the number is not a square number? Okay, so we're going to do one example on the board and to show how we can solve or find the square root of a number which is not a perfect square. Okay, so let's have a look at, let's see. Say, for instance, the square root of the number 10. 10 is not a square number, so how am I going to find the square root of 10? Okay, the first step here is to identify two square numbers. The first one that occurs before the number 10, and the second square number which occurs after the number 10. Okay, so let's see. Square root of 10. The first square number that occurs before 10 would be 3 times 3, which is 9. Okay? And the next square number which appears after 10 is 4 times 4, which is 16. So the two square numbers that we are using are 9 and 16. Okay? So you're going to take the square root of those numbers, root of 9, then add them together, plus root of 16, and divide it by 2. Okay, so root of 9 is 3, plus root of 16 is 4. Divide that by 2. Okay, 3 plus 4 is 7. Divided by 2, which is equal to 3.5. Okay, now, in order to find the square root of a number that is not a square number, we use estimation. We've just done that on the board. We are estimating. Now, this equal sign will not be straight like this. It should be curved like a pair of waves, okay, which tells us that that's an approximate answer or the closest answer to the correct one. Okay, so if you have a calculator, you should check the root of 10. On the calculator, you will get the value 3.1622. Okay, that's very close to our estimate here. All right. Now, we can look at another number, maybe a larger number than 10. So now let's have a look at an example of a number that is larger than 10, but also not a square number. Let's look at the number 40. Okay, so let's see the square root of 40. All right. Now, again, step 1 is to identify two square numbers that appear or occur before 40 and another one that occurs after 40. All right. So the first square number would be 6 times 6, which is 36. All right. Then there's 40. The next square number after 40 is 7 times 7, which is 49. Okay, so we're using the square numbers 36 and 49. Let's go back here. Find the square root of 36 plus root of 49. Then divide by 2. Okay, root of 36 is 6 plus the root of 49 is 7 divided by 2. Okay, 6 plus 7 is 13 divided by 2, which is equal to 6.5. Okay, now again, if you have a calculator or you have access to one, make sure you go and you use the calculator to find the root of 40, and your answer should be very close to the estimate we have here on the board. Okay, now that's the end of the first segment of our lesson. In the next lesson, we will still be looking at square roots, but how to calculate the root of very large numbers and calculating the square root of very small numbers.